Okay, so now that you understand the basics of factoring, we're going to go into some higher degree polynomials. So as a reminder, degree is the highest exponent of the polynomial. So if you're looking at this problem number 1, the degree here is 3 because 3 is the highest exponent on this problem. Looking at number 2, you can see that 4 is the degree of this problem because 4 is the highest exponent. So we're going to start factoring higher degrees. So we're going to go to 4th power, 5th power, 6th power, so on and so forth. Okay? So first, always check for a GCF. Hopefully you already said that before I finished. You should be checking for a GCF always, because even with higher degree polynomials, if we can find a GCF first, that is automatically going to make the polynomial easier to factor. Okay? So let's go ahead and start with problem number 1. As I'm looking throughout problem number 1, I noticed a couple of things. So I'm going to write to the side here. First thing I notice is that there's 4 terms. I also notice that if I reorder it, we have some groups with GCF. All of this are things that I'm looking at before I even start the problem. So I'm going to go ahead and use grouping method because of what I have identified here. So what I'm going to do is I'm going to reorder the problem like I said. Okay. Again, you don't have to reorder, but I just like my odds better if I reorder. Okay, so we have x cubed minus x. I'm going to put those together, and then I'm going to put the negative 5x squared with the 5. Okay, so now I have 2 groups. In the first group, the GCF is just x, and then I'm left with x squared minus 1. In the second group leads with a negative, so I'm going to make sure to factor out a negative GCF. So I'm going to take out negative 5. And then you'll see I'm left with x squared minus 1. Okay? And then lastly, I'm just going to put the 2 GCFs together that I took out, which is x minus 5. And then here's my common factor, aka the twin. And we're done. Oh, sorry. We are not done. We're done with the first couple of steps. You want to make sure that when you think you're done, you look at the problem, analyze it, and see if there's any more that you can do. So as I'm looking at this, I see here that this is a difference of squares. And so I can't really do anything with x minus 5, so I'm just going to go ahead and bring that down. And then x squared minus 1 would factor as x plus 1 times x minus 1, following the difference of squares pattern, which is a plus b, a minus b. Okay? Number 3, a couple of things that I notice here is 1, the degree is 6. So that's a higher degree polynomial. Higher degree polynomial means we should probably use substitution. Use substitution. Now this is a new concept. Substitution. Okay, this is a new concept. You haven't learned substitution yet. So I'm going to introduce it now. What substitution does is it takes a higher degree polynomial and it's going to make it a lower degree polynomial so that it's easier for us to factor. So the purpose is that it's easier to factor. Okay, easier to factor because high degree will change to a low degree. high degree changes to low degree. And you know how to factor low degree polynomials already. You know how to factor third power. You know how to factor second power. So when you see us do the substitution, you're going to see, oh, I actually know what to do after a certain step, okay? All right, so let's go ahead and use substitution. I'm going to use the letter U for my substitution. So again, substitution is just replacing something with something else, okay? So I'm going to say that U is going to be x to the third power. So anytime I see x to the third power, I'm going to replace it with the letter U. This is very important because you're going to have to start to notice that other powers can be rewritten as x to the third power. For instance, the problem starts with x to the sixth power. Well, x to the sixth power is the same as x to the third power squared. So I can rewrite x to the sixth power as u to the second power. So again, let's go back through it. X to the sixth power can be written as x to the third power to the second power. So that means since u is x to the third power, I can now write this as u squared. See that? So now x to the sixth is u squared. So I'm going to rewrite the problem. I have u squared minus 26u. There goes that x to the third power. So I have to write that as u now. Minus 27. Now, look at this very simple trinomial that I'm sure you know how to factor. Here, the leading coefficient is 1, right? We have an invisible 1 out front. So since the leading coefficient is 1, you would factor this using trinomial factoring, or in other words, known as the X method. Okay? So the X method says we're looking for two numbers that would multiply to negative 27, but when you add them, you get negative 26. So we can now factor this as u minus 27 and u plus 1. Last but not least, in this method, you want to go back and change u to what it was originally. U is x to the third power. So we're now going to change it back. X to the third power minus 27 and x to the third power plus 1. Okay. Again, we may think we're done, but you need to double check. I notice here that this is a difference of cubes. X to the third is a perfect cube, and 27 is also a perfect cube. And because of that minus sign, this is a difference of cubes. Even further, I can now look at the next factor. This is a sum of cubes. X to the third power, again, is a perfect cube. 1 is also a perfect cube. So, in the first set of parentheses, the first factor, x cubed minus 27, I'm going to follow the difference of cubes pattern, which is a minus b, a squared plus ab plus b squared. And for sum of cubes, we're doing a plus b, a squared minus ab plus b squared. Okay, so first we need to identify what a and b is. Identify what a and b are. Okay. So in order to break down x to the third power, this is going to be x times x times x. Let me try to squeeze it in here. X times x times x. 27 is 3 times 3 times 3. Same over here, x times, oh, why did I change the color? X times x times x, and then 1 is 1 times 1 times 1. Okay? Okay, so for the difference of cubes, we're going to be doing x minus 3, that's a minus b, and then a squared is x squared. A times b is 3x. B squared is 9. Now for the sum, for the sum of cubes, x cubed plus 1, we're going to factor that as x plus 1 for a plus b. A squared is x squared minus a times b is just x because 1 times x is x. And then b squared, 1 squared is just 1. Okay. Now we factored that out and we're probably looking at it like, I think we're done. But let's double check. This is fully factored. X squared plus 3x plus 9. Are there any factors of 9 that could add up to 3? No. Factors of 9 are only 1 and 9 and 3 and 3. So that's done. This is also done. Are there any factors of 1 that could add up to -1? No. Only factors of 1 are 1 and 1 and -1 and -1. So done. Which is normally the case. If the numbers are small enough, normally after you factor difference of cubes and sum of cubes, you should be done. If the numbers are small enough. So that problem is done. And so this is our final answer. Okay. Let's move on to number 5. Number 5 is another high degree polynomial. So here the degree is 4. The degree is 4. So again, if the degree is 4 and there's no GCF, okay, there's no GCF for 1, -13, and 40. So your A is 1, your B is -13, and your C is 40. There's no GCF for those 3 numbers. So degree 4, no GCF, we want to use that new method we just learned, which is substitution. Okay? Also known as U substitution. Substitution. Okay? Substitution is when you're going to replace one of your variables with a different variable in order to decrease the degree of the polynomial so that it's easier for you to factor it. So, I'm sure you were thinking in the last example, how do I figure out what I'm going to substitute? So let's do that. We know we're going to be using U here. We're going to use U. But what will I use for U? What you're going to do is you're going to look at the terms that have the variable. So these are the 2 terms that have a variable. And you're going to take the GCF of those terms. So again, you're going to look at the terms that have the variable, and you're going to take the GCF of those terms. So when I'm looking at x to the 4th and -13x to the 2nd, the GCF here is x squared. So that's what U will be. U will stand for x squared. So now we're going to rewrite the polynomial, and anytime we see x to the 2nd power, we're going to replace it with a U. And be careful of those hidden x's to the 2nd power, right? So if you look at the first term, x to the fourth is x to the second power to the second power. So this is u squared. Okay? So when we rewrite the polynomial, we're starting with u squared minus 13u plus 40. Now I have a much simpler polynomial to factor here. Are there factors of 40 that would add up to negative 13? We have u will be factoring as u minus 5, u minus 8, because negative 5 minus 8 is negative 13. Okay? And then last but not least, you need to replace u and put back x squared. Okay? So this is actually going to be written as x squared minus 5 and x squared minus 8, since u was equal to x squared. Okay? And last but not least, we just want to make sure that that is fully factored. So can we factor x squared minus 5 any further? No, this is not a difference of squares, so that's done. And can we factor x squared minus 8 any further? No, because that's not a difference of squares either. 5 and 8 are not perfect squares. So these are not difference of squares. Done. Let's move to number 7, okay? All right, again, we have a high degree polynomial, so you're probably thinking, just because you saw the 6, that this is going to be substitution, okay? Possibly, it could be substitution, but what were you supposed to look at first before you looked at that 6? You should be looking for a GCF, okay? There is a GCF here. The GCF here is x squared. So we're going to factor out x squared and see what's left. We'll have x to the fourth minus 4. Okay? All right. Now, is there any more we could do here? There's nothing we can do to x squared. However, this x to the fourth minus 4 is a difference of squares. We have a difference of squares here. Why is this a difference of squares? Because you have two perfect squares. X to the fourth is x squared times x squared. And 4 is 2 times 2. So with difference of squares, you're going to factor that as a plus b times a minus b. Okay? Oh, so sorry. So we're going to go ahead and bring down the GCF, which was x squared in the beginning. We're going to bring that down. And then following the difference of squares pattern, we'll be writing x squared plus 2 and x squared minus 2. Done. Okay? We're actually done this time. This is done. X squared plus 2, there's nothing you can do there. Even if it was a sum of squares, I mean, we could use complex numbers, but 2 is not a perfect square. This is not a different square. 2 is not a perfect square. So, done, done, done. Awesome. Let's move to number 9. Oh, what's going on here? Okay. Wait a second. Why? It's glitching. Okay, hopefully I edit that part out if I remember. If not, you'll just have to watch it glitch for a while. Okay, so here we have a higher degree polynomial again. High degree normally means substitution, right? As you've learned now. High degree normally means substitution. We're just going to check to make sure we don't have a GCF before we start doing substitution, because you always should check for a GCF. So The A here is 2, B is 1, and C is -6. Do those share GCF? No. Do they all share a variable? Could the GCF possibly be a variable? No, because 6 doesn't have an X. Okay, so there's no GCF, so we're going to go straight into substitution. Now again, with substitution, you want to establish what is U. What is U? How do you do that? Look at the terms that do have the variable and take their GCF. So the GCF of 2x to the fourth and x squared will be x squared. So what are we going to do with that? We're now going to replace anything that can be written as x squared with a u. So we will have 2u squared, because x to the fourth is x squared squared. So we have 2u squared plus u minus 6. Okay. Now let's look at this problem and see if there's anything that we can perform here. This is a little bit different than the ones we've been doing. Normally, we would look for two factors of this number that would add up to this number, but we cannot do that in this case because a is not 1, a is 2. So in this situation, we're going to slip and slide. So we slip 2 to the 6 and we get u squared plus u minus 12. Now we're looking for two numbers that multiply to -12, but when you add them up, you get 1. That is going to be 4 minus 3. Okay, 4 times -3 is -12, and 4 minus 3 is 1. Okay, after you slip, you have to slide. So you can't just stop here. We are now going to divide by the 2 that we slipped in the beginning. Okay, so now we have u plus 2 and 2u minus 3. Okay. Remember, we can't stop here. We do have to replace the u again with x squared. So now we have x squared plus 2 and 2x squared minus 3. Is there anything more we can do here? Not quite. Okay, so we are done. X squared plus 2 is done, and 2x squared minus 3 is also done. Number 11. Okay, number 11 has 4 terms. I'm looking at those terms and I'm seeing that it is possible for me to have a GCF. So in the first group, in the first 2 terms, it looks like there's a GCF of x squared. So in this group, the GCF is x squared. And in this group, the GCF is just -1. That's all they have in common. Okay? So, first group, what we have left over here is 4x minus 1. And then here, also 4x minus 1. So next we want to put our GCFs together. So we have x squared minus 1, and then the common factor is 4x minus 1. Is there anything more we can do? Let's check. For x squared minus 1, this is a difference of squares. Difference of squares. So we'll be factoring that as x plus 1, x minus 1. And then the 4x minus 1 is already fully factored. So we're done. I don't know if I mentioned it while I was doing it. I don't think so, but this is grouping. Okay? 4 terms. And each group had a GCF. Okay. Number 13. First, I'm analyzing. I'm seeing that there are 3 terms only, which is great. There's 3 terms. There's no GCF for these 3 terms. 5, 24, and negative 5 do not have a GCF. 3 terms with no GCF, we're just going to slip and slide. Okay? So we have x squared plus 24x minus 25. Then I'm looking for 2 numbers that multiply to negative 25, but when you add them, you get positive 24. So that's going to be x plus 25 and x minus 1. So 25 minus 1 is 24. Then I want to slide, right? Slip and slide or slip and divide. I got to go back and divide. So we have x plus 5 here, and then here we have 5x minus 1. Check to see that it is fully factored, and it is. So we're done. Oh, that was a nice one. A nice break from all the u substitution and craziness. Okay. For number 15, same situation. There's no GCF for 4, 4, and 15. No GCF, 3 terms. It's only the second power. So this is just your regular slip and slide or just trinomial factoring. So I'm going to skip that because we literally just did it. Okay. Oh, great. Now we get to solve. So we have an equal sign at the end. So we're actually going to be solving. Solving a polynomial. So this is solving. Solving a polynomial means that you're just finding the x-intercepts. Find x-intercepts, like on the graph. You're trying to see where on the graph will this polynomial go through the x-axis. Where is this going to go through the x-axis? Okay? All right. So we're going to go ahead and start. I see that it's third power, so this could possibly mean that this has to do with difference or sum of cubes. So let me look at the numbers. We have 64 and 125. This is definitely sum of cubes. Definitely, because 64 is a perfect cube and 125 is also a perfect cube. So this is definitely sum of cubes. Okay. But I can see that the polynomial leads with a negative in front. So I'm going to go ahead and take that negative out. And then you'll see what happens here. So when I take out the negative, I'm left with 64x cubed, positive 64x cubed, minus 125 equals 0. So this is actually going to be a difference of cubes, okay? All right, cool. So now inside here I have a difference of cubes. So I'm just going to follow the difference of cubes pattern. So first I need to break down 64x cubed as 4x times 4x times 4x. And then 125 is 5 times 5 times 5. Great. Now, following the difference of cubes pattern, which is a minus b times a squared plus ab plus b squared, I'm simply going to factor this as 4x minus 5 times 16x squared plus 20x plus 25. Okay? And of course, outside, I still have the negative that I factored out in the beginning.